A fluorescent molecule is one that's capable of absorbing a short wavelength of light and re-emitting a longer wavelength. In this test tube I have a molecule called fluorescein, a very commonly used fluorophore. This light source here is a blue LED, so it emits blue light, but when I shine the blue light on this fluorescent molecule, you will see a different color of light emitted. I will do this in the dark. Alright, so there's my blue LED. Here's my fluorescent solution, and you can see that we get a nice green glow out of the fluorescein when illuminated by blue light. So this is the principle of fluorescence. It is a very sensitive method. We can detect quantities in the nanomolar concentration. Our fluorometer looks like this. It's a very big box. It's computer controlled. To turn on the machine, down here there are 3 switches which are done in order. First, the farthest one. Next, the middle one, which is red. And finally, the white one. So this is the correct starting sequence for the fluorometer, and must be done in this sequence so that you do not harm the machine. The fluorometer uses cuvettes, similar in concept to those used in a UV spectrophotometer, but all 4 sides are clear in a fluorescence cuvette. Light comes in from the side, and you measure the light output from the front face. Light in, light out. For fluorescein, the fluorescence is dependent upon pH, and we want a pH at least pH 7 or above, so I'm going to use this tris buffer here, which is pH 8.5. Minimum volume recommended is a milliliter. I'm actually going to use 2 milliliters. So you can see that fills the cuvette about half full. This fluorescein is at a concentration of 5 micromolar, and I want to dilute that to 0.1 micromolar. That's 100 nanomolar. So that requires 40 microliters of my fluorescein. To my eye, this is a completely transparent solution. I don't see any color in it. The machine, however, will be able to detect the fluorescence of 100 nanomolar fluorescein. The chamber opens here. Inside is a compartment where the cuvette will rest. It doesn't push all the way in as it does in a spectrophotometer. The light source is right here. You can't really see it. The light detector is right there. Close the lid before taking any measurements. Now we go to computer control. Lumina software is the folder that holds the various types of measurements that we can do. The one that is typically used is wave scan. So that brings up this screen here. It also wakes up the fluorometer. I hear a sound. To start collecting data, we click on this button in the corner that says New. And now it says, what do you want to call this experiment? I will call this experiment, so go test Jan 8. In this case, I could give this a title. I'll just leave it as test. So now you can see there is a graph that comes up, intensity on the y-axis and wavelength on the x-axis. So similar in concept to a UV spectrum, but in this case we're measuring the emission of light, and counts will be how many photons were were detected. The controls for the experiment are in this corner here. Typically, the scan mode that you will be using is emission. This means we're looking at the colors of emitted light. We're looking at the spectrum of emitted light. You could, although, choose excitation. You're saying, I want to decide which wavelengths excite the molecule. I will leave this on emission. Data mode, fluorescence. That in some reactions make their own light, in which case you would do luminescence, but this is a fluorescence measurement. The most important control here is this Pmt voltage. Pmt is photo multiplier tube, and depending on this voltage it controls the sensitivity of the machine, rather like a volume control. Crank up the Pmt voltage and you'll get a higher spectrum reading. I will adjust this to 450 volts, which I believe will be an appropriate measurement for this sample. I'll hit apply. Another important tab to click on is this wave setup, because I need to tell the machine what is my excitation frequency and what wavelengths do I want to scan. For fluorescein, the recommended excitation wavelength is 490 nanometers, and I will collect a spectrum looking at the fluorescence from 500 to 600 nanometers. That looks fine. It's going to look at every nanometer between 500 and 600. Alright, that looks okay. So now to actually collect a spectrum, up here is a button that says start and stop. And this will be a mini graph of wavelength versus intensity, and I will click on start. So there you can see it's collecting data there, and it does so very quickly. It takes a little while for it to get started, but once it starts, it's very quick at acquiring data. So here it says the data has been saved, so I say okay, great, thank you for saving the data. So here's my fluorescence spectrum. We can see here that the peak emission is close to 510 nanometers, a little bit between, well, it's between 510 and 520 nanometers is the peak emission. By the time we get out to 600 nanometers, there is no light of that color being emitted. So this is in the green, and then this is the yellow over here, and this would be getting out to the orange. So we're predominantly green in color, and that is the fluorescence spectrum from my sample. To show you the idea of how the Pmt voltage makes a difference, I will try 500, and we'll rerun the spectrum with 500 volts as the Pmt. So this is like turning up the volume. My spectrum here is actually pretty good already. There's no reason for me to turn up the volume, but we'll do it just to show you what it does. Again, I click on start here. There, it's collecting its spectrum, and it will put that data onto my graph. So now I have two samples, sample 1, sample 2. This is the one with a higher Pmt voltage, and you can see it made a big difference in how many photons were collected. This is above 10,000. The peak last time was about 4,500. If I want to look at only one of these, I can remove one from the graph, get rid of sample 1 by clicking there, bring it back by clicking there. So sometimes you want to run comparative spectra, and that would be how you do it. This data can be printed, and I believe it can also be saved in an Excel file. I have not yet figured out how to do that. In the end, I will clean out my cuvette with distilled water. This is aqueous chemistry in this case, so no need for organic solvents. If you're shutting down the fluorimeter for the day, the sequence is reversed. So the white is pressed first, and the red follows. The recommendation from the manufacturer is that you do not turn off that last switch, which runs the cooling fan, until 5 or 10 minutes have elapsed. So I'm going to let this run for about 10 minutes, and then I'll turn off the final switch.